start again. 14, 10, 2. So, any questions that has popped up during the break? Everything is crystal clear. The reason actually that I did not do any sequence diagrams and stuff like that was that I think that the design was kind of stable for what we had already done. It was kind of like more of the same. The implementation we did not really add that much to the design, but it followed the design we already had. It would be, of course, possibly be another thing to do if we have something new that we need to think more about. Then maybe some upfront design is good. But for these two new requirements, this was more or less just added to the existing design, and everything worked out really well. We did some refactoring, and we're kind of like good to go. However, the next thing I think we should look into is this concept of the dealer. Now, we could take a look at the start new round code here, and this is kind of like an algorithm for starting a new game in a certain way. And this is for American Blackjack, I think, when the dealer has this hidden card at the end. And maybe we would like to have a European version of this also. How should we add this to get the dealer to play with European rules for starting the new game? Any suggestions? A base dealer? Yeah, that could absolutely be one possibility. I think we could actually make it a lot simpler. We could just add the European dealer and just override this start new round code. So we don't need to make a nifty interface or a base class or something like that. We could use the polymorphic operations that are available to us. And this is also one of the grasp patterns. So let's go back to actually writing something on the smartboard. It was a long time ago, so maybe he has recovered. Polymorphism. So the problem is, what should you do if you have behavior that varies based on the type? So in our case, we had the American dealer, that is one type of dealer, and we had the European dealer, and that is another type of dealer. And the behavior of starting the game now. So, okay, sorry for that. We are talking about the grasp pattern polymorphism, and the problem that we faced in our implementation is we would like to have another kind of rule for starting the game. We had American rules now where the dealer has a hidden card, and we wanted to add European rules where the cards of the dealer are open, or Swedish rules or whatnot. So we have this variation of behavior of starting the game in two different ways based on the type of dealer. And this is what the polymorphism pattern, grasp pattern, is all about. And the solution is to use the polymorphic operations that we have available. So we can override the implementation that we already have and add new behavior for this. So this is what we will be doing right now. I guess you're all familiar with polymorphism since your basic object-oriented programming courses. So this should not be really that surprising, at least. So let's just add a, we can copy this dealer, and we could maybe call him Euro dealer. And the only thing we should actually do is override start new game round and show this last card also. Not the most dramatic change maybe in behavior, but it should at least get the point done. This should be removed. No, that should be left. So let's try and compile. That seemed to be working, and we also actually need to not create this dealer, but the European dealer instead. And the dealer now has two cards that are visibly shown. We have the 3 of clubs and the Knight of hearts, and it was hidden of hidden before. So this is an example of how you can use the polymorphic operations to change the behavior that you want to change. And you should use these polymorphistic behaviors instead of adding funky type of variables, use some kind of reflection, add more states to the class. These are common things that I see in code often. Oh, let's just add use American rules, Boolean variable stuff. And you add a lot of if statements and stuff like this. So we also have a few other grasp patterns that I will just write down. We have pure fabrication. And that is actually just the opportunity we have in the design to just make something up. If we can't find anything good in the domain model, if we can't find anything good in our current design, we can make something up. We are free to invent new classes that support low coupling, high cohesion, and stuff like that. It does not need to reflect reality in all cases. We can make things up in the design also. Indirection is the use of a middleman, so to speak. We want to avoid coupling two classes directly to each other. How can we achieve this? We can put a middleman in between them to handle these dependencies instead. It is almost a little bit like those layers that we had in the architecture. Okay, we don't want all the layers to be dependent all on each other, but only the layer below, and so on and so on. So we put in this middleman to avoid couplings directly from the application or user interface to the database, for example. And we have protected variations. And that is the general principle for handling parts in your design that you think will change a lot. We will have a lot of change in this area. So we need to protect the entirety of the application from these changes, from these variations that we have. So we should strive to encapsulate these hotspots in our design, and hopefully maybe be able to build some kind of stable interface around them. That would be the best option, of course, and handle the variations inside of this component, inside of this class, inside of this subsystem, or at least get the compiler to react on these dependencies that we might have and get a compiler error, or we should strive to get assertions, or we should strive to get exceptions, or at least have automatic testing, or in the worst case, manual testing. So try to protect your application by using encapsulation of variable parts. So I think that is all actually for the grasp patterns. You can read more about them in the book. We have applied a lot of them in our blackjack game, and especially the information expert. That is kind of like the basic pattern. We have thought about high cohesion, low coupling to get better design. We have used the creator pattern and the polymorphism pattern. I don't know if we have made something up. You could actually say that our architecture, the model view controller architecture, it's like, okay, we make up the view. That's not something that exists in reality, and we make up the controller also. Those are fabrications, something that we use to avoid mixing the user interface into the domain model. And you could maybe see the controller as a version of the indirection pattern, a middleman that sits between the model and the view and coordinates them. And we have maybe thought a little bit about protected variations, trying to protect ourselves from variations in the cards, colors and values and stuff like that. So I think we will now go towards the gang of 4 patterns invented by, or not maybe invented, first described by Gamma, Helm, Johnson and Blisides in their book Design Patterns, Elements of Object-Oriented Reusable Design, or something like that. It's a really good book and you should read it and get it. It will go over many more patterns that are in our course literature and that we cover in our lectures. And if I'm not mistaken, we have already actually talked about one such pattern, and that is the observer pattern that we used as an example in the dice game to get a notification of when a die was had got its value, because we added a small delay there. So first things first, we should add our little euro dealer here also. Something like that. So we could imagine now that we have the problem of, okay, we have this variation of rules in how to start the game. And we could imagine finding other funky ways of starting the game and adding other variations there also. We have two right now, American and European. You could probably invent more. We could also say that, okay, we would like to have variation in how the rules for who wins the game works. Okay, we would maybe like to add the blackjack rule there, 21. We would maybe like to let the player win if scores are equal, or something like that. So we can imagine some variations there also. We could also imagine some variations for the rules when the dealer should take a card. There is such a variation called soft 17. For example, in the rules. And that is when the dealer has 17, so according to our rules right now, he should not take a card. But if he has 17 in the combination with an ace, that is counted as 11, he can get a card valued 10 and still have 17, because the ace's value will be 1. And that is the soft 17 rule. So this is another rule variation that we could imagine. And we could, of course, imagine others also. And in our current solution, we would deal with this based on inheritance. So we would then not only have the euro dealer, we would maybe have the euro dealer, soft 17, player wins on equal. And then we would add another type, euro dealer, soft 17, dealer wins on equal. Do you see where I'm going with this? We have 2 variations, we have 4 variations, we have 8, 16. So we quickly get an explosion of classes. For every type of variation we have, we need to add a lot of new classes. That is maybe not a good thing. Something is coming here in the chat. We will see what Svante has on his mind. Or we can have a config class with rules, and in the menu choose what rules to follow. Yeah, of course we could do something like that, but the implementation would be needed somewhere of these rules anyway. And the current implementation we right now have is to, okay, let's do a new dealer with these variations in it. And we could use that, could let the player choose in the menu what type of game he would like to play. Instance this new dealer and use it in the game. So that is an option. I don't know if it's really that what you were thinking about, but we have this problem of exploding number of combinations of types here. That is not a good thing. So fortunately there is a pattern to handle this, and it's one of the Gang of 4 patterns, and it's one of the basic Gang of 4 patterns, and it's called strategy. So, and the basic problem is, how can we support the design for variation in an algorithm? In our case, okay, we need to support changes in the different algorithms of starting a game, of deciding who to win, of doing these kind of different things. So the first thing we should do is create an interface to encapsulate the algorithm. And we let each algorithm variation become a class of its own and realize this interface. So we have this client. We have this client, we have an interface for the algorithm, we have different algorithm variations. In different classes that realize this interface, and the client only sees and uses this interface. So in our case, the client would be the who. Okay, let's think about it. Let's think about what is it that we want to vary. We want to vary the rules for starting the game. Who is using the rules to start the game? dealer, yeah, the dealer is the client. We will probably name our interface I start new game strategy or something like that. And here we will have American, for example, or European, or whatever we can find out. So let's implement this. I also think that we should add a new namespace here, a new package, and let's call it rules. And we will have this interface to start with. And this is also something to notice, the naming of the type, naming of the class, the interface. Try to use these pattern names, because when you as a developer then stumbles upon these names in your implementation or in someone else's implementation, you will know the design, since you know the pattern. So you won't have to look at the class diagram to understand how this works. So we should have this. No implementation allowed, of course. So we should now take a look at, okay, we should start a new game. We actually named it Start New Round, but whatever. What is happening here? We are taking cards from the deck and showing them or not. And that is basically what is happening. Taking cards from the deck, dealing them to the dealer and to the player. So we need to have access to the deck, and we need to have access to the dealer and to the player. So these are the arguments that we need here. Possibly this will work. Also notice that I'm not sending the dealer type here. I'm not using an object of the dealer type, because all we need is access to the player functionality. So we should not give the opportunity to do other stuff in these implementations that we will find. So something like that, I will just try to compile, and we will see what is happening. We probably need a lot of stuff like this then. So let's do some implementation of this, and we could probably, let's copy this. And European. And in this version, we should just do it like, we could maybe take those also. So we move this algorithm of starting the game in the American way to this algorithm. And we need to use this one here instead. Something like that. Oh. Errors. MDEC. ADEC. 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 Duplicate class, yeah, I think we probably have not changed this one, so let's do that. So, we have the implementations now, I think. No, we don't. Ah. Attempting to assign weaker access privileges. Yeah, I think we just need to have public. So, we should just go out into the game class here. We should have the ordinary dealer. And yeah, let's just do some quick and dirty implementation here. Something like that, I hope. Cannot find symbol. I hope this will do it. No. Cannot find symbol class I start new game strategy. Oh, it's new game strategy. So, hopefully now everything will run and we will have the American rules once again. New game. Now we need to recompile the main also. So we get the hidden of hidden last. Quit. So we can now remove this, and we have moved the code out to the algorithms for starting a new game has been encapsulated in 2 different variations that implement the same interface. Can someone see a very bad thing right now in this implementation? Well, maybe it's just the fast and dirty coding that I did, but thinking about it, we've made a lot of trouble to protect the dealer from variations in the different algorithms for starting a game. So we want to protect the dealer from these variations, but we are here creating a specific type, a specific instance of a specific type here anyway. So we right now have a dependency from the dealer into this American new game strategy. So this is not a good thing. So obviously the dealer should be parameterized in some way instead. So it should only see the interface. It should only be dependent on the interface. And the way to do this is foremost in the constructor of the dealer. So it needs rules to be able to play. The rules for starting a new game, and we should send these rules into the dealer when we start it, yeah? I think you should inject into the constructor if it's not optional, so to speak, to have this. In this case, the program can't work without the dealer having some kind of rules for starting the game. So it's not an option to leave this out. So then I think it should be injected into the constructor. You could also add a method for it to maybe change the rules during the gameplay. So we have created a dealer with some kind of default rules, and we can have change these rules as we play. So you could add a method for that also then. But if it's important for it's an illegal object to have a dealer without rules for starting the game, then you should definitely have it in the constructor. So it should be this, and this should not be here, but rather somewhere where the dealer is created, and right now it is here. So this is the place right now to add this parameter. Let's compile. Dealer. Yeah, okay, we probably need to remove this. This one, let's just do it like that for now. So we have the American rules, quit, and we could just make a quick test with the European rules and see that everything is working. I think it's what like that. And we don't have the hidden cards anymore. So we can now parameterize the rules of the dealer. And we have started with the start new game rules. And in this way, if we add the same concept, the same pattern, we use the same strategy pattern for our other variations, we actually only need to implement the variations we need. And we can compose our dealer with different combinations of these rules. So we don't get this explosion of subtypes. So for 6 different algorithms for starting and hitting and selecting who is the winner, we would just have 6 subtypes, 3 interfaces and 6 subtypes for totally, for 2 for each, instead of like a lot. Questions? I think we made good progress today. I will commit the code and upload the videos ASAP. I urge you to try this code out, make your own experiments, add a new rule variation of your own, a new way of starting the game if you want to. It is maybe the only way to actually learn this stuff is to try it out yourselves. Maybe you can find opportunities in other projects and stuff you have going on for using this kind of thinking. Yes, I'm done. If there's no questions, we will finish up, and I will hope you will have a nice week and nice weekend, and I will see you next week. Yeah, bye for now.